42 photographs, each with a 30-second exposure, were captured on a tripod aimed at a consistent section of the sky to observe the effects caused by atmospheric turbulence and optical aberration. Let's first play these photos sequentially to see the effect of Earth's rotation on the celestial sphere. Let's also increase the playback speed for a quicker view. Next, by stacking all the photos on top of each other, we will create a single image to obtain what are known as star trails. Although the southern celestial pole remains below the horizon, the circular movements of the stars around it can be easily seen. Next up, playing all the photos aligned so that the stars stay in the same positions. Defined as irregular fluctuations in air currents, atmospheric turbulence leads to effects such as changes in the positions and brightness of stars, known as the wandering effect and scintillation effect, whereas off-axis aberrations and distortions, which are more pronounced in wide-angle lenses, cause changes in position and shape, increasing from the center to the edges of the image. Let's zoom into the center of the frame to take a closer look at what atmospheric effects look like. Even with a zoom in, the distortions at the corners dominate over atmospheric effects. Finally, let's zoom out and play it at a slower speed. Now, instead of changes in brightness, let's stack all the aligned photos, as in the previous example, to examine the clear positional changes of the stars. What we see here is a combination of atmospheric turbulence and optical aberrations. And finally, let's stack all the aligned photos again, minimizing distortions caused by optical effects, and process the image appropriately to clearly see the Milky Way. Here's the result.